this new chapter, we're going to talk about logarithms. Today, day one, our learning target is I can switch between exponential form and logarithmic form. I can evaluate a logarithm without a calculator. We'll start with learning our exponential form and our logarithmic form. Remember, exponential means exponent, so something with an exponent. Here we have b to the power of x equals y. And if we were to write that same equation in logarithmic form, we would read log base b of y equals x. Again, that's read log base b of y equals x. And if you notice, there's a b in both equations, an x in both equations, and a y in both equations. And that is what helps us go from one form to the other. So this problem says, write in logarithmic form. Write in logarithmic form. So we want to have a log in our final answer. We know we're going to start with writing log. Our base b, or our base in this case is a 9, gets written kind of tiny and a little bit lower. And then so log base b of y, that's what's on the other side of the equal sign. That is our 81. Equals what would be the exponent is 2. This is now written in logarithmic form. We'll try another one. This says 1/5 to the negative second power equals 25. So log base is 1/5 to the power of what's on the other side is 25 equals the exponent is -2. Now we'll go the other direction, write in exponential form. So this new thing that you write should have an exponent in it. So we need our base, here it's 2, to the power of what is on the other side, to the 5th, equals 32. And we know that 2 to the 5th power, 2 times itself 5 times, does in fact equal 32. For one more example, our base to the power of what's on the other side equals 1, and we know anything to the first power always equals 1. So now we're going to evaluate logarithms, and we don't need a calculator to evaluate these problems. We have our steps written right here, so step 1, set equal to x. Step 2, change into exponential form. That's what we just did. So our base 3 to the power of what's on the other side equals 81. So 3 to the x equals 81. We want to solve for x, so our question is how many times does 3 need to be multiplied by itself in order to get to 81? So 3 times 3 is 9, times 3 is 27, times 3 is 81. That tells us that x equals, sorry, that's an equal sign, equals 4. X equals 4. We'll look at another example. All right, so evaluate log base 1/4 of 64. Step 1, again, we're going to set equal to x, and then we're going to rewrite it. When we rewrite it, we have 1/4 to the x equals 64. So we've got a couple things we need to figure out here. We know that 1/4, that means that our bigger number is on the bottom. So somehow that exponent needs to be a negative so we can get it flipped back up to the top. So here we know x is negative. And we would also say 4 times itself. How many times will give us 64? 4 times 4 is 16. Times 4 is 64. So we have 3 times. Therefore, we know that x equals -3. All right, we're going to do two more examples here. Log base 10 of 0.001. Again, same idea, set equal to x, rewrite it. Oops, too many zeros there. If we wanted, we could also rewrite this, instead of having decimals here, it might be easier to rewrite this as 10 to the x equals 1 over 1,000. Then it kind of looks like the previous problem where we know x has to be negative, and we would say 10 times itself, how many times will give us 1,000? And we know that x equals -3. All right, here we have log base 64 equals 1/2. I'm sorry, log base 64 of 1/2 equals x. I misread that, but we can rewrite it as 64 to the x equals 1/2. Before we were saying what number times itself, how many times will give us our value, but this time we want to do the opposite. We want to take a root, so the root of 64, not the square root this time, but in this case we're going to do the 6th root, because we know 2 times itself 6 times will give us 64. And we know x must also be negative to get our equation flipped to be over 1. So we can say x equals -1/6. And if we look at that, we can say 64 to the -1/6 power equals 1/2. I think I said only two more examples, but we are going to do one last example. This problem is written a little bit differently. This one says 5 to the power of log base 5 of 7. We will set this one equal to x. And in this case, since it's already written in exponential, we're going to rewrite it in log form. So log base, our base is 5, of x equals the exponent, which is log base 5 of 7. And we're going to get into some properties a little bit later, but one property I can tell you right now, if it's a log with the same base, the two things equal each other, which means that this will equal this since they are both log base 5. So x equals 7. Your homework is written in another file in this folder, and have a great day.